In this video, we are going to look at the problems in section 5.1. We're only doing a couple of these because the others require information we haven't gotten to yet, and we'll talk about them next time. So in this first problem, we're asked to find the mean, variance, and standard deviation for this probability distribution. It's a pretty simple one. It's just talking about the number of heads that are expected when we flip a coin. The probabilities that we get 0, 1, or 2 heads. So, back over here, we start by calculating the mean, and that has a formula of sigma equals x times, sigma of x times the probability of x. So that's the sum of the value of x, say 0, times the probability that we get that value, which is 0.25, plus 1 times 0.50, plus 2 times 0.25. Well, obviously, 0 times 0.25 is 0, plus 1 times 0.5 is 0.50, plus 2 times 0.25 is 0.50 again, which gives us a mean of 1.0. Next, we look at the variance, which is given by the sum of the square of x times its probability minus the square of the mean. Well, here we get 0 squared times 0.25 plus 1 squared times 0.50 plus 2 squared times 0.25 minus 1.0 squared. Okay, so that's 0 plus 1 times 0.50 is 0.50, plus 4 times 0.25, which is 1, minus 1. Therefore, our standard deviation, our variance rather, is 0 plus 0.5 plus 1 minus 1 is 0.50. Finally, we come to the standard deviation, which is just the square root of the variance as we've seen before. To calculate this, we just take the square root of the variance we've already calculated. So that's the square root of 0.50. And we take that square root. And we see that, should actually press the square root button, there it is. Okay, so that comes out to about 0.7. So sigma equals 0.7. Moving on, we come to this problem. Once this stuff shows up, here we go. We previously found that when tossing 2 coins, the mean number of heads is mu equals 1.0, and the standard deviation is sigma equals 0.7, which is what we just calculated. Using those results and the range rule of thumb, determine whether 2 heads is a significantly high number of heads. Well, a number is only significantly high if it is greater than or equal to mu plus 2 sigma. Mu plus 2 sigma is equal to 1.0 plus 2 times 0.7, which is 1 plus 1.4, or 2.4. Now, obviously, you can't get 2.4 heads on 2 flips of a coin. So no, this 2 is not a significantly high number of heads. There we go. That's it for this video. If you have any questions, please do get in touch.